Okay, finally, chapter 4, section 6, our final section on transformations. We've talked about rigid transformations and we've talked about dilations, which are non rigid. And what happens is when you combine all these together, right, you're not going to have a congruent transformation, right? Congruent means they're all the same size and this, the same size essentially, right? Regardless of their orientation. But as soon as you introduce dilation, you're not having congruent anymore. And so for that reason, we refer to the transformations with a dilation in them, we refer to them as a similarity transformation because they're actually not congruent anymore, right? Take a look at these different shapes here. They are similar shapes, that's for sure. They may be in scale to each other. We'll see in a few minutes here, but they are not congruent. Okay, the size is literally changed. So we're going to change the language a little bit and refer to them as similarity transformations. And but our task is still the same here, right? They're giving us the old, they're giving us the new, and we're trying to figure out what just happened here. So we are asked to, in our example for this section, is to graph triangle ABC. That's this guy right here. Okay. With vertices 0, 1, 0, 2, and 2, 1. Okay. And its image after the following transformation. Okay. So the transformation they first want to do is take this blue guy and translate him to the right 3 and up 1. Okay. So that means this one becomes here. This one becomes here. And this one becomes here. Okay. That's the first transformation. In this case, just moving it. Next, I also need to dilate with a scale factor of 2. Okay. Now, this is my new thing here, right? This is my B prime. This is my A prime, and this is my C prime. These are the coordinates right here. 3, 2, 3, 3, and 5, 2. Boom, boom, boom. Okay. Next, we apply our dilation of factor 2. A dilation of factor 2. So a dilation of factor 2 would mean this x and this y would be 2 times bigger. 3, 3, 2 would be 6, 4. 3, 3 would be 6, 6. 5, 2, 10, 4. So what that means is after both after both transformations are done, what used to be here is now here. Alrighty? And that's what we're going to be asked to do in today's daily exercise. That's essentially what we're going to be asked to do. Now, we're going to be asked to describe it, okay? So how does one become something else, right? That's what we're trying to figure out. So describe a similarity transformation that maps trapezoid PQRS, that's the blue one here on the left, onto the green one. Boop, boop, boop. Alrighty? So that's what we need to do. Now, here's what's going to happen. First, I can clearly see between this one and the prime that this reflected across the y-axis. So that's the first step I'm going to take. A reflection across the y-axis. That's the flippy flippy. Now we're talking about the red one. Now, this red one becomes the green one. Clearly, it got smaller. Okay? So clearly what's happening here is we have a dilation of a factor of, I don't know yet. Okay, so let's take a look. Let's pick a point. All right, here's a point right here. This point is 2, 1. This one matches this guy. And this point here is 1, 2, 3, 4, 5, 6. Okay, so he is 6, 2, 3, 6, negative 3, 7, 1. Okay, now y over here. Okay, how far is this dot from this dot? This is 2. How far is this dot from this dot? This is 6. So what used to be 6 is now 2 times smaller. Excuse me, 3 times smaller. See how this red one is 3 times bigger than 2? Okay. This 2 is 1/3 of 6. Now, let's take a look at from a different perspective. That's just the bottom horizontal line, right? Going up and down, how long is this line right here? 2. How long is this line right here? 6. So again, we see 1/3. Dilation factor of 1/3. Notice how 1/3 is less than 1. And for that reason, we realize it's probably, getting smaller. Of course it is. We're looking at it. It's reduced. Okay. That's what today's work's going to be about. It's not going to be easy. It's not going to be obvious, but talk to your friends, talk to me. It could be more than one answer. Now, somebody else could have answered this question and gone in a different order. You could have dilated first, right? And then reflected. We could have just made this blue one smaller and then reflected. That could have worked too. Lots of different ways of considering how to do this. All right. So use your imagination, follow the rules, and if you have any questions, let me know.